15.6, solving radical equations. Kind of had an idea this is probably coming. You know, eventually you learn about all these radicals, learn about everything, learn about radical expressions. Eventually we're going to end up solving things. So let's kind of look through the method here real fast. Get my pen out here. All right. Notice what we're going to do is we're going to have to come in here and we're going to solve. Okay, so come here a second. Yes, that, yes. Okay, what's going to end up happening is, as you see on number 1 here, we're going to have to isolate one of the radicals. Okay, that just means that you're going to have an equation. Sometimes one side's going to have a radical, which is great. Sometimes it says here an equation may have more than one radical. Sometimes it's going to be very easy, sometimes it's going to be hard to kind of isolate it. What we're going to do is, just like whenever you did the absolute values, okay, we've got to get it into kind of like a standard form, and you can't see me, but I'm putting that in quotations, okay? Then we're going to raise both sides of the equation to the power corresponding to the index of that radical. Okay, that's saying it's basically taking the inverse. Okay, because remember, if you have like a cube root, okay, well, whenever I take the power of a cube root, square root, remember, that's just going to remove that and just leave us with the x. That's what we're trying to do. Okay, if the equation still contains a radical, complete steps 1 and 2. Okay, so that's literally how this is going to kind of continue on. Solve the equation after the radicals have been eliminated. That's literally solve for the variable, and then be sure to check all possible solutions. Okay, this right here is very important. Very important, because sometimes, okay, it's not going to work out that both of your answers are going to make the solution true. So you want to make sure that whatever the solution is, that it works, okay? Because it's not always going to be that way. Sometimes you're going to end up with one solution. Sometimes you might end up with 2 solutions, okay? Either way, you want to make sure that they work. Okay. So let's do an example, and then, like I said, once again, I sound like a broken record. We're going to do a bunch of these, okay, in class, talk about them, but also you'll see some on your notes here. So first things first, let me go ahead and rewrite everything. And we're going to have y squared minus 10y minus 11 all to the, we've got a square root, okay, equals 1 plus y. First things first, come over here and get I'm going to put a parenthesis around everything, and I'm going to come in here and square everything. Notice on this side, whenever I do that, that's going to leave this side as y squared minus 10y minus 11 equals, be very careful here. Remember, I cannot do this. I cannot distribute that power. This right here becomes 1 plus y, 1 plus y. Okay? You cannot distribute that power. Okay? Because of that little operator, that little plus operator right there, that stops it. Had this just been multiplication or division, I could do that. But because there's a plus, or maybe there might be a minus in there, I cannot do that. Okay? So here, this side is fine. Looking over it, notice we don't have any more radicals, so now we're just going to go ahead and start simplifying everything. I'm going to FOIL this right here. Okay, so I'll just say FOIL. Okay, when I do that, what's going to happen here? Let me change back. I'm going to end up having y squared minus 10y minus 11. Well, 1 times 1 is 1. And then I'm going to end up having 2y. So I'm going to have plus 2y and then plus y squared. Now, it's literally, let's get everything over to one side. Okay? Well, let's look it over here. Notice I've got a y squared here. I've got a y squared here. Let me get out another color here. So I'll subtract off the y squareds. Well, now I no longer have a quadratic. That's good news. I'm only going to end up having one answer, so we can kind of continue on. looking at this very carefully. It doesn't really matter how you do it, so let's just kind of just say you weren't paying attention and you decide to say, well, I'm going to go and subtract off this 2y, subtract off this 2y. Well, once I do that, I'm going to have to add the 11 here, and then add the 11 here. That is going to end up giving me a negative, oops, don't know why it does that every once in a while. Let me make sure to erase that random line. Okay, well, whenever this is going to be gone, okay, this right here, those are gone, and what else is gone? This is gone right there, those have gone. So we've got negative 10 minus 2y, which is going to give us negative 12y. Here I've got 1 plus 11, this is going to give us 12. I'm going to switch colors right now. We'll go and just divide off the 12, divide off the negative 12, pardon me. And our final answer is going to be y equals, well, this is going to be a negative 1. Okay. Don't just stop there. Take the time. Make sure everything works out. So let's come back up there. Okay, look at our original equation, but we're going to plug back in negative 1 back into the original. So let's go ahead and write this a little bit differently. Let's do this in blue. I'll do it in like a kind of an ugly green. Okay, so we're going to have, well, negative 1 squared minus 10 times negative 1 minus 11, stretch it out just a little bit, equals, well, 1 plus a negative 1. Okay, continuing on, notice this right here, this negative 1 squared, that's just going to end up being a 1. And then right here I've got a negative times a negative, so that's going to end up being a plus 10. Keep the minus 11, all under the square root. This right here ends up being 0. This right here, whenever you do it, you're going to end up having 1 plus 10 is 11. 11 minus 11 is going to be 0. The square root of 0 is 0, and 0 can equal 0. So yes, our solution does work out, everything works out, and all is happy in the world. So there we go, we'll kind of keep doing this and kind of keep doing more stuff in class and more examples.